So in today's video, we'll talk about what is batch versus streaming ingestion, and we'll try to understand what batch ingestion actually means, what streaming ingestion actually means, and what are the differences between both of them, and then what are some of the key things that we need to consider before picking streaming or batch ingestion. And of course, we'll conclude this video by saying which one to pick and in which scenarios. Okay. So before before talking about like anything technical or before getting into like details, so maybe let's try to let's try to talk about a scenario which kind of gives you an overview or a little bit idea about streaming and batch ingestion and when to pick which one. Okay. So imagine, let's say you are working at a food delivery platform or food delivery company. Okay, like it can be Uber Eats or it can be DoorDash, or if it is in India, it can be like Swiggy or Zomato. So what will be happening in that food delivery platforms or food delivery apps is normally there will be like millions of people around the world or around the country, like who will be sitting in their homes and trying to place the orders, right? So basically orders are happening constantly. And then what happens is, so you try to order normally some food from some restaurant. So when you click on place order, what happens in the background is the restaurant, whatever the order, whatever you are trying to place the order from. So the restaurant receives the order, and then there will be a driver who accepts it, and then the driver reaches the restaurant, and normally he picks up the food once it is ready, and he will start driving. And normally during all this process, the customer is literally will be staring at the phone while all this happening, right? And he will be like kind of staring at the phone, customer will be staring at the, he or she will be staring at the phone in real time. Okay. So normally what happens is, so whenever you try to open your phone, what you will normally see is, for example, you'll see something like order placed as soon as you place the order, right? And then after that, you will see order prepared, something like this, right? And then once order is prepared, then it will be picked up. It will be picked up by the driver, and once the order is picked up by the driver, then you will see how far is it from him delivering the order to your location. It might even say something like he's 3 minutes away now. And at the end, once he's arriving your location, then you might see the update like arriving now. So all these things you are basically seeing it kind of real time, right? Now imagine the same system. So now imagine the same system, let's say it is getting updated only once a day, maybe at midnight. So that means that if you have ordered the food right now, but if you only see the update tomorrow, then it doesn't sound so correct, right? Because here real time information is not luxury. Okay, it's part of the product experience, whatever the product, wherever the product you are trying to order the food from. It can be like Uber Eats, or it can be DoorDash, or it can be Swiggy, or it can be Zomato, it can be anything. Okay, so here basically the whatever the real time updates you are seeing, they are not like luxury information, right? They are part of your product experience that is basically embedded into the product. Okay, so here in this case, so what is happening is everything is basically you would see streaming ingestion happening in the background. There might be like there will be some data engineers sitting somewhere in those companies and working. So they might have built some streaming platforms. What they will be doing is so immediately as soon as you place the order, they will be gathering the data, collecting the data, and then they will be sending you all these updates in a real time way. Okay, so in this particular scenario, so if you are getting the updates like, for example, even though now you are getting the updates in real time, but let's say if you are getting the updates only once in a day, or maybe once in an hour, or once in 2 hours, okay, like, okay, then it's basically not good, right? It's actually kind of ridiculous, to be honest. Okay, but So here I would say real time is necessary, okay? But now let's talk about another scenario where real time is probably not that necessary, okay? Maybe let's say you are working in an organization, or you are working in a company where you have some payroll department and HR department and all that stuff. So at the end of the month, what normally happens is, okay, you will work for whole month, and for in order for you to like work, since you worked there for a whole month, you will normally receive salary, right, at the end of the month, okay? But then here, um, you don't need to know each and every second or each and every minute how much salary you earned, okay? So I hope that makes sense. So here you don't need to know, you don't need to know, for example, for each minute, let's say you earned maybe some 0.00237 dollars or something. You don't need to know that. So you just need to know maybe at the end of the month or at the end of the week, like if you know how much salary you earned, that would be enough, right? So here you don't need to kind of recalculate your salary, your payroll, like each and every second or each and every millisecond, or each and every minute or hour as well. Okay, here you just need to know, maybe probably if the payroll updates even once a week or once a month, that would be fine. Okay, nobody complains as long as it is correct information, whatever it is. So as long as your correct salary is getting reflected in the dashboard, that's totally fine, or at least to you, then that's totally fine. So the reality is, some workloads absolutely require real-time processing, because waiting breaks the product experience. Waiting breaks all the user experience, and it creates like huge amount of risk in some cases, okay? And other workloads, other workloads, here also called as like batch workloads, are perfectly fine even if they are being delayed, okay? And running them continuously, okay, creates unnecessary cost and complexity. So and that difference, that is business need versus timing, okay, is exactly why batch ingestion exists and why streaming ingestion exists. So you need to understand your business needs in order to kind of make a decision, or in order to kind of in order for you to like kind of make a decision to pick whether you need to go with the streaming ingestion or batch ingestion, okay? So and in today's video, we are going to talk about both, okay? If you don't know what is streaming ingestion means and what is batch ingestion means, that's totally fine. We are absolutely going to talk about them in very detailed and basic way, okay? Not in the tool first way, of course. We are going to talk about it from from business perspective and from fundamentals and basics and concepts perspective. Yeah, so we are going to kind of understand what is batch ingestion actually means, and what is streaming ingestion actually means, and what are the differences, and when to use which one, and what are the key considerations for picking the right type of ingestion for your needs. And then we'll of course conclude by saying or conclude by summarizing what we have discussed in today's video, okay? So, and again, here I'm not going to talk about whether you need to use Spark structured streaming or Kafka or event hubs or all that stuff. Okay, so this video is mainly about understanding the real question, which is, does the business need the data immediately, or is delayed processing perfectly fine? And in which of these cases we actually need to go with which of these ingestion we listed here, okay? So let's talk about the section 1, or the part 1 of the video, which is understanding what batch ingestion actually means, okay? So now we are going to talk about what batch ingestion actually means. So yeah, I'm pretty sure if you are a data engineer, let's say, who has been working in the industry from long time, or even if you have just entered the industry, or if you are like a entry level data engineer or even mid level data engineer, you might have probably already heard this term called batch ingestion. But let's understand what does it actually means. So batch ingestion is basically when we collect data for some time and then process it together in one shot, okay, in one shot in a batch, that's called batch ingestion. Okay, so what I'm saying is, so in batch ingestion we'll collect data for some time, right, and then process it in one shot, okay, in one shot or in one batch, okay, one batch or one group, then it's called batch ingestion. Okay, basically, and that batch could run, let's say, every 5 minutes, or it could run, every 30 minutes, which is half an hour, or it could run, every 1 hour, or half a day, or basically every once in a day as well, or it can be, nightly batch or weekly batch as well. Okay, or so this is on the timing level, or it can even be like, for example, when data reaches certain size, like maybe 10,000 rows or 15,000 rows as well, then also we can say that that batch could run. So to say what batch ingestion really means is, it means that it's basically when we collect data for some time and then process it together in one shot or in a batch, then that's called batch ingestion. And that batch could basically run like every hour or every 5 minutes or every once in a day, or even when the data reaches certain size, like 10,000 rows or 15,000 rows or anything like that. Okay, that's called batch ingestion. So if you still don't understand what batch ingestion actually means, let's try to understand with a little bit more of, a little bit kind of vague example. So let's say there is a post office and there is a postman. Okay, so what he normally do, what he or she normally does is, so they will be receiving some kind of letters in their post box, and then as soon as they receive the letters, they won't immediately deliver letter by letter every second, right? So what they normally do is they will group the letters, they will sort the letters, and then they will process or deliver the letters. Okay, so if you observe, so they are waiting until some particular, okay, some group of letters or some quantity of letters they get, or they are waiting until, a certain point of time is reached, and then they are collecting all the letters until that point of time, and then they are grouping and sorting them, and then they are processing them. So same happens with data as well. Okay, so we will, in batch ingestion, we will collect data for some time and then process it together in one shot. Okay, in that's called batch. Okay, and that's called batch ingestion. And maybe let's also talk about a little bit more of, real life or real time examples, so that it feels a little bit concrete. Okay, apart from all the vague example we just talked about. So let's say you have a payroll in your company. Payroll is the one who normally pays the salaries, okay, to the employees in that company. So um, let's say there is payroll processing happening. Okay, normally when payroll happens is like, usually it's monthly, right? So payroll runs every month. Okay, at the end of the month or at the beginning of next month. Okay, so for payroll processing, there is no value in updating salaries like every minute. Okay, so here accuracy matters more than speed, right? So here you could get away with batch ingestion. And if you want to talk about a different example, let's say there are tax reports. Normally what will happen is we have to file the tax, right? So we have to pay the tax to the government, and then we can do our preliminary assessment and all that stuff. But then normally this tax reporting, they won't they run kind of quarterly or yearly, right? So they won't run like every minute or every second. So here time is not the priority. Here mainly the priorities with respect to tax reporting is like auditing and correctness. So they are the main priorities. So it won't make sense to kind of run tax reporting or payroll processing like every minute or every second. Okay, so here batch ingestion would be absolutely fine. Okay, so even if we have to talk about like other example, let's say you have some kind of business dashboards. Okay, so what happens with the business dashboards is these often like update every 30 minutes or maybe every 1 hour, or even once in a day. Okay, nobody nobody in most of the cases, none of the business people are actually making the decisions like second by second. Okay, so obviously they are here they are mainly not concerned about live data. They are mainly focused on observing the trends and then making the data based on the trends. Okay, so in these cases actually you don't need the real time or streaming ingestion. Okay, here you could get away very well with batch ingestion. Okay, so to summarize a little bit about batch ingestion, batch ingestion normally works well when no one needs real time data or decisions. When no one needs to make decisions on second by second basis. Okay, so when no one needs to make decisions on second by second basis, or when no one needs to make real time decisions, then batch ingestion makes absolutely perfect sense and it works really well. Okay, and other point when batch ingestion works well is like when the delay does not affect, when the ingestion delay, to be precise, when the ingestion delay does not affect business outcomes, then also batch ingestion works well. Okay, so when the ingestion delay does not affect business outcomes, then also obviously batch ingestion works well. And then also when all you need is, or when all the business people need is summary or aggregated data. Okay, then also batch ingestion usually works well. Okay, and to be honest, batch ingestion is like quite simple, affordable and super reliable. Okay, since why it is affordable in the sense like since you are running it like every 1 hour or every once in a day, so it is kind of affordable, so you don't need to burn a lot of compute to do the batch ingestion. So that's why it's simple and affordable and also reliable. And for many of the years, like for decades actually, batch ingestion was the default approach. Okay, in any of the data teams, and mostly because yeah, like it was also the default approach because because the infrastructure for real-time streaming was not like mature at all back then. Even now actually there is a lot of infra available where you can do like provision managed infra, or you can maintain the infra by yourself. But also at the same time, streaming ingestion like always comes with a lot of challenges that you need to address. And if there is no like cost to benefit, then it won't really make sense to like go with the streaming ingestion. So if you know what I mean. So this is about batch ingestion. Batch ingestion is when we collect data for some time, or when we accumulate data for some time in the source, and then when we load or process all the data in one shot, essentially in a single batch, then that's called batch ingestion. Okay, and batch could run every 5 minutes, or every 30 minutes, or every 1 hour, or once a day, or half a day as well. Or also when data reaches some certain size like 10,000 rows or 15,000 rows or 50K rows as well. Okay, and yeah, and batch ingestion works really well when no one needs to make like real time decisions, or when no one needs to make like second by second decisions, right? And batch ingestion also works well when ingestion delay does not affect business outcomes, and when all you need is summary or aggregated data, then it works like super well. Okay. And if you are wondering about what does ingestion delay means, so it's um, it's basically what happens is data will be created in source, and then data will be arrived in the data platform, right? So the difference between these times, okay? So the platform arrival time minus source creation time is called ingestion delay. So I just want to clarify that before moving to the streaming ingestion. Yeah. So now, so this is what batch ingestion is mainly about. Now let's try to talk about streaming ingestion. So yeah, I hope you understood a little bit about the batch ingestion. Now we are going to talk about streaming ingestion. Yeah. So streaming ingestion means that data usually flows continuously into your data platform, and that's like within, like we are talking when we say data flows continuously into the platform, usually here we are talking about like milliseconds or seconds, from the time when data is being produced to from the time when you are receiving the data in your data platform. Okay. So to put it in simple way, so streaming ingestion usually means data should be flowing continuously into the data platform. Okay, usually within a span of like milliseconds or seconds. Okay. And if we say for example, batch is like a snapshot. Yeah, if you say batch is more like a snapshot, then we can say streaming is like a live video feed. Okay, streaming is like a live video feed. So obviously, now you might have already be like familiar with the word like streaming. Nowadays there are many streamers like who will be continuously like keeping the internet on and recording what they are doing and stuff like that, right? So it's basically live video feed. So you can kind of think streaming as live video feed where you will be kind of receiving the data in continuous manner, like every second or millisecond or micro or nanoseconds as well. And when we talk about batch, we are actually talking like a snapshot. Okay. So yeah, and streaming becomes like really necessary when, okay, streaming becomes necessary when waiting creates risk. When waiting creates risk for business. Okay. So when waiting creates a risk for business, then streaming can become like really necessary. And also it can become necessary when waiting breaks the user or product experience. When waiting breaks the user slash product experience. Now, what do I mean by waiting breaks the user or product experience is, so imagine at the starting of this video, we talked about food delivery apps, right? So in case of food delivery apps, imagine instead of you getting the updates every second or every minute, imagine if you are getting that updates like once in a day, then there is basically no purpose to like getting updates once in a day, right? Because if you have ordered the food, you would want to know like where is your order, and then you want to know your order status and how far the order has reached your home, and in how many more minutes will you be receiving your order. So you would want to know all these details, right? But if all this data is getting updated like once in a day, it basically breaks the user or product experience. And that's when streaming becomes necessary. That's when you don't want to use batch ingestion. That's when you want to use streaming ingestion, right? And also streaming becomes necessary when waiting blocks decisions that must happen instantly or immediately. Okay. I'm saying when waiting blocks decisions that must happen instantly. Okay. let's say business has to take some decisions, or or even some machine has to take some decisions like immediately or instantly. But then if you are updating the data only on a hourly basis or only on nightly basis, then you probably can't make decisions like in real time fashion. So it kind of blocks the decisions, and this is when like streaming becomes like ultra necessary. So so streaming becomes necessary when waiting creates risk, or when the waiting breaks the user or product experience, and waiting blocks the decisions in that are supposed to be like taken instantly. Okay, that's when streaming becomes necessary. So let's try to break down with some real world use cases. So let's talk about maybe fraud detection, right? So also the first point here, we are talking waiting creates risk for business. Okay, so for that perfect example would be like fraud detection. Okay, so here actually speed directly affects money. Let's say in fraud detection, what will happen is, for example, let's say you have an credit card or debit card. Okay, if your card is somehow like your card got stolen. Okay, but somehow that stolen card is being used, then we need to stop the transaction before it completes, right? Not after it completes. We need to stop it before it completes. So that's when streaming becomes necessary. Okay, so otherwise it is just creating the risk for your business. It is putting your business at risk, business of your company at risk. So that's why here streaming becomes necessary, because here you want to take the decisions immediately. When I say you, might not be you, as in general, it might be the machines who has to take the decisions immediately as well. Okay, so otherwise it is creating kind of the risk. So for example, like the fraud detection case. Okay, so and also let's talk about some other case which is like super common, which is stock trading. Okay, so in stock trading, what will happen normally is there will be traders who will be trading different kind of stocks like um, on live. For example, you might have observed that some people or some traders will be sitting at the monitors, and then they will be continuously following the price movements and everything, and all the candlesticks and everything. And normally what happens is their prices will be changing like literally each and every second, right? And here in this case, even like a minute delay or a 30-second delay can literally change the outcome of entire trade. Okay, so that's actually now a big risk, and we don't want that to happen. And this is when also streaming becomes like super necessary. Okay, and again, we have also talked about ride sharing apps or food delivery apps. So those are also, um, those are also the best cases for when streaming becomes necessary, because tracking a car or a delivery is part of the product experience. Okay, it's not like you should not be able to, it should not be like where you should be able to track once in a day. Okay, you should be able to track like live. So and that's built into the product experience, and that's why like here streaming is like super necessary. Okay, and streaming is actually, I would say, it's not at all about like being fancy. It's about enabling decisions that basically cannot wait. Okay, so you should always remember that. So now that's one of the most important point. So let's try to probably write it down. So I'm saying, so streaming is not at all fancy. Streaming is not at all fancy. In no way streaming is fancy. It's about enabling the decisions that cannot wait. Enabling the decisions that cannot wait. Okay, it's mainly about that one. Okay, and yeah, now that's about streaming ingestion. And then now we should still talk about the decision framework in the sense, for example, we should know when to pick streaming, or when to go with batch ingestion, right? Of course, we have talked a little bit about when streaming works well and when it becomes necessary, and then we have also talked about when batch ingestion works well and when batch ingestion is necessary. But then maybe let's try to kind of figure out some kind of decision framework which will help us to kind of pick, you know, which will help us to understand whether we should pick like streaming ingestion or batch ingestion. Okay. Now, now before picking like a batch or streaming ingestion, like any experienced engineers, like, or even if you are like junior or mid-level engineer, we should basically have some kind of mental checklist and we should go through all that checklist. Okay. And again, yeah, I'll probably like correct my wording. I know I said like mental checklist. I'm not literally saying you should have all this checklist in your mind. Okay. So I'm saying like you should have this checklist and somewhere maybe even in notepad or somewhere, okay, whatever you, wherever you want to keep your decision framework. And then we should, you should go through it before picking like any kind of ingestion. Okay. And I hope it will be obvious, it will at least be a little bit obvious, on picking between either of these two. Okay. So one of the first most important question that we need to ask ourselves before going with any kind of ingestion is, okay, we should answer the first and foremost important question, that is, can your downstream systems handle real-time data? Okay. Can your downstream systems handle real-time data? Real-time data or real-time events, right? Sorry. So let's say if your Power BI dashboard, let's say you have some Power BI dashboard and it is refreshing like every 1 hour or every once a day. So here basically there is no value for streaming, right? So here there is like absolutely zero value streaming the data like every second. Streaming only helps like when the consumer also needs real-time data, or when the consumer can also handle the real-time data. So if the consumer applications are not able to handle and process the real-time data, then also probably you should reconsider why you want to do streaming in the first place. Okay. And then second most important question, or second most key consideration that we need to talk about is, do you need milliseconds real time, or is micro batching usually enough? Okay. Do you need millisecond, do you need millisecond real time events, or micro batching is usually enough? Okay. um, most people ignore the fact that micro batching actually exists. So people usually talk about like batch ingestion and then streaming ingestion, which are kind of extremes in their own ways. But then the middle ground is also kind of like micro batching, even though it's a little bit inclined towards streaming ingestion. But it might be the balance you might be looking for in most of the cases. Okay. So sometimes I would say you actually don't need like true streaming. Okay. Processing, for example, every 30 seconds instead of milliseconds, or every 1 minute, or even every 5 minutes, feel real time to the users. Okay. For example, let's say you are using some gaming platform, and then you might have saw that like in most of the gaming platforms there will be normally the leaderboard available, right? And that leaderboard, it won't be updating like every half a second or every 5 or 10 or 100 milliseconds, right? So updating it in milliseconds or every half a second, see, can be like super overkill, and it can be like super costly. So maybe updating it like every 15-30 seconds or every 1 minute can also feel real time, and can be like much cheaper as well. Okay. So you need to consider whether you need like millisecond real time, or micro batching would just do the work for you. Okay. And then and then the most important point I would say is, what business benefit does streaming give you? Okay, what business benefit does streaming give you? So at the end of the day, so I am emphasizing again, we are data engineers, and then data engineering is about like converting that raw data to useful data and useful to the business people for them to take decisions, right? You should always keep that in mind, okay? And if the streaming, let's say you have choose to go with the streaming ingestion, but if it is not giving you any business benefit, then you should question yourself, okay? Streaming should basically unlock new possibilities or new capabilities, okay? For example, in case of fraud detection, blocking bad transactions instantly is quite good, right? It's giving you some kind of business benefit, okay? And also in case of like delivery tracking as well, it's improving like customers trust and customer experience or product experience, by providing the live updates, so that's nice, okay? But something like, let's say there is some billing report or payroll processing, so yeah, so if it is like, if these things are updating even though in every minute or every 2 minutes or even every milliseconds or seconds, they won't give you any kind of a benefit. So you won't gain anything from using streaming in case of payroll processing or billing reports, right? So like you do in fraud detection or delivery tracking, for example. So yeah, if streaming does not change the business outcome, then probably batch ingestion would be a better choice, okay? And then moving on, you should understand, what does actually streaming cost you, okay? We should understand streaming costs, okay? So what I mean by streaming costs is, we actually need to pay like super close attention to the pricing or the costs involved in streaming, because it's like you are doing streaming ingestion, which is like data is flowing continuously, okay? It's not going to stop, okay? And if you are, for some reason, if it is getting stopped, if your computer is getting stopped, then there might be some messages which will be like, which might go missing forever, right? So for streaming, so you normally need like most of the time 24/7 compute. So you should have your compute on like 24/7, okay? And you should have like nice monitoring capabilities, okay? And then you should have failover systems or strategy for failover, okay? So in case if some systems are failing, then how would you want to handle the missing events, and how would you want to handle the idempotency, and how would you want to handle the ordering and all that things, okay? And you should also know about like scaling the infra, since the data is flowing in real time. So you really sometimes can't expect like when the data grows in the source system. So sometimes you might get like 10K or 10,000 events, and sometimes you might end up getting 1 million or 100K events, so you won't know. So you should have you should have a strategy for scaling the infra well whenever you are dealing with streaming ingestion, okay? And then uh, and then most important point, so in order to be able to do any kind of ingestion, not just streaming, okay, you should have skilled engineers, okay? You should have skilled data engineers who basically understands how distributed systems work, okay? So so you should have them as well. And in my experience, getting um, this point right is like a little bit difficult most of the time. Skilled engineers, in the sense like people think in terms of technology and tools, but skilled engineers actually understand the fundamentals and basics behind all the data concepts or all the software engineering concepts, and that's really important. And in this case, yeah, um, yeah, so streaming also requires skilled engineers who basically know about distributed systems, and of course, skilled engineers are also like pretty costly to get. So they're not cheap at all. And And in contrary to batch ingestion, which can run during low traffic hours and often less significant cost, see streaming actually costs you like really high. Okay, so if there is no that business benefit to the cost, then you should actually question your approach. Okay, so that's also again one more important point that we should touch upon. And then the next important point would be, what happens if the system fails? What happens in case of failure, right? So again, as I mentioned in the previous video, you should always design your data pipelines or any kind of logic with failures in mind, okay, and evolve from it basically. So sometimes, let's say in batch ingestion, you might rerun the job and then it's a simple and then it's done. But in streaming, you will actually need a lot of strategy and you need to think about a lot of things, um, for handling the failures in streaming. For example, you need to think about replay logic, right? And you need to think about checkpointing. You don't want to process the same data again and again, right? So you need to have strategy for checkpointing, and you need to consider idempotency, right? And then you also need to, of course, worry about ordering the events. And then you should also, of course, think about durable queues. So basically what will happen, so there will be some sources which will be pushing the streaming data into the message queues, but then if the queues are not durable enough to handle the incoming events, then they might as well fail, and we don't want that to happen. So, and what I'm basically saying is you need to consider all these things, or maybe more actually, like replay logic, checkpointing, idempotency, ordering, and durable keys, and all that stuff. And it's generally much more harder compared to the batch ingestion. Okay, and then moving on to the next point. So next point, which is about tools. Okay, whether we should use fully managed or self-hosted tools. Okay, so which ones we should use, which ones we should consider? So basically, if your team don't want to manage the infrastructure, managed solutions like Snowpipe or event hubs or PubSub would be easier. But if your team need full control, you might end up running like Kafka or Pulsar or Flink or Spark Streaming. But of course, at the end of the day, someone must maintain them. So, and those will be the skilled engineers that we talked about here. Okay, and then moving on to the next point, which is are you using machine learning, and does it need live predictions? Okay. Okay, are you using machine learning, and does it need live predictions? For example, let's say we talked about fraud detection. Yeah, for fraud detection, yes, you might use machine learning, and of course you need to do the live predictions. And yes, in this case, streaming is meaningful and like super necessary. But for like, let's say, churn prediction, okay, here maybe batch would be like very fine, right? Yeah, and then moving on to next point here, will you need to also ask yourself, will ingestion overload the live production system? Okay, will ingestion overload the live production system? Okay, let's say you are pulling the data continuously from some relational database, or from basically your operational database that your company might be using, for powering your applications or operations, right? So if you are, let's say, if you are pulling data continuously from that relational production database during office hours or during work hours or business hours, then that might slow down the transactions for the users. Okay, So, and if it slows down the transactions for users, then they might lose interest, and they might look for different alternatives, and we don't want that to happen. So, yeah, we always need to question ourselves and find the right answer. So sometimes maybe batch or CDC or CDC replication is much more safer. Okay. So yeah, these are some of the key considerations that we need to always keep in mind when picking between streaming versus batch ingestion. And whenever you are designing ingestion, always try to ask one more important question, that is, does real time change what business can do? Okay. So does real time data can change what business can do, in the sense like, if it is able to change how business reacts to some certain situations or certain events, then that's fine. So if there is some business benefit, then that's totally fine. But if there is no business benefit, basically there is no cost to benefit. Okay. So because streaming is like really expensive, and most cases like batch is like super simpler and cheaper and reliable and perfectly valid for most cases. So before you jump on build a streaming solution, so just pause for a second and ask yourself, what decision will change, okay, if the data arrives immediately into your data platform? Because in my opinion, at least, great data engineering or great engineering in general is not about using the flashiest technology. Okay, it's about choosing the right solution at the right time based on how the business actually works. Okay. So I'm going to repeat this again, so because it's a really important point and we should understand it. Okay. So before we build, or before we jump onto like building any kind of streaming ingestion, we should always pause for a second and ask ourselves, what decision will change if the data arrives immediately into our data platform? Because great data engineering or great engineering is not at all about using the flashiest technology in the market. Okay. Because at the end of the day, we are going to get like see a lot of flashiest technologies and tools from all the Silicon Valley companies, and from all the different parts of the world. There will be like new data engineering tool and technology emerging like each and every day and each and every month. But knowing how to use that technologies won't make you like great engineer or great data engineer. Okay. It's about like choosing the right solution at the right time based on how the business actually works and based on what creates the value for the business. Okay. That's what makes you a great engineer. Okay. You need to have problem solving mindset, and then you need to understand the problems that business are usually facing while taking the decisions, and you need to try to have a strategy and mindset for addressing those solutions, and that's what makes you great engineer. And I would say actually that's what also gives you like satisfaction in your professional career. So yeah. So, and I hope if you have liked this video, please like this video and share and subscribe to the channel, and comment down. Like, I'm really curious to hear which kind of ingestion are you actually using in your current projects, whether it is like streaming ingestion or batch ingestion or micro batching. I'm really curious to hear from you guys. And I will, of course, going to come up with the more interesting topics. And until then, stay tuned, and see you and talk to you in another video. Until then, stay tuned. See you. Good night.